All right, let's find the critical values for number 5. So first we need to figure out the derivative. I'm going to go ahead and use the quotient rule for this one. So derivative f of x, derivative of the top is 2x times the bottom minus the regular top times derivative of the bottom, which is 5, all over the denominator squared. So I'm going to go ahead and simplify things a little bit, distribute on top, and combine like terms. So we end up with 10x squared plus 8x minus 5x squared, all over 5x plus 4 squared. So our final simplified version of our derivative, we get 5x squared plus 8x all over 5x plus 4 squared. Now we want to figure out when is the derivative equal to 0 and when is the derivative not exist. Well, normally, just to find out when the derivative is 0, we set this whole thing equal to 0. Well, if we go ahead and multiply both sides by this denominator, really all we end up with is that numerator set equal to 0. So when finding when the derivative is 0, and we have like a fraction, expression looks like a fraction, we can go ahead and just set the numerator equal to 0 and solve for that. So here we can take an x out. So we get two solutions, x equals 0 and x equals negative 8/5. And we want to check back in the equation to make sure that these fit in the domain. We could put 0 in, we get 0. Put negative 8/5 in, we're going to get a number over a number. We're not going to like be dividing by 0 or anything, so that's okay. These two solutions are critical values. Now, with the second part, finding out when the derivative does not exist, well, that would happen if the denominator was 0. Right? Then we'd be dividing by 0. So we want to set the denominator equal to 0 and solve for that. So we can take the square root of both sides, and we get 5x plus 4 equals 0. And then subtract 4 divided by 5, we get negative 4/5. So this looks like it would be another critical value, but like I said earlier, you want to check this. If we put this back into the function, does it give us something out? Is it in the domain? So negative 4/5 squared, we'd get 16 over 25, that's fine. But if we put negative 4/5 back into the denominator, we end up getting 0 in this denominator also. So that means it does not exist in this function, right? It's not even part of the domain of the original function. So for this one, this is not a critical value. It's not part of the domain of f. Right? It's not in the domain of f. Right? It's not in the domain of the original function, so it cannot be a critical value. There isn't even a point there. So, a little shortcut on this one for you in the future. Whenever we're using quotient rule to take the derivative, you don't even have to bother setting this denominator equal to 0 because that denominator is just going to be the original denominator squared. So if it makes this 0, it's going to make the original one 0 also. It's not going to exist there. So quotient rule problems, you can skip this step. We couldn't skip it on number 1 because this wasn't quotient rule. We don't have anything in the denominator here. So this positive or negative 2 is not going to make this undefined, the original function. Right? Only with those quotient rule ones can we kind of skip that step.